So why do I say electricity is plasma? It's well, it's all coming out soon. But the idea is when we charge up a magnetic field, we charge up. We use big um, magnets, and we use copper wire, and all these wires are one big molecule. So a lattice of copper is a giant. We melt it and shape it as we want, and we make a giant connected magnetic field from point A to point B. And when we polarize one end, we polarize the other end. We're not polarizing the nucleus of the atoms because they're stuck in their position in copper. So what happens is we don't create a lot of heat like we would with iron, because that allows the polarization of the protons to bounce back and forth. We don't want that. That'll create heat. We use resistors for that, to generate like the electric stoves and stuff like that, light bulbs, all that other stuff. So what happens is we're charging up that field, all right, with a positive and negative about 50 to 60 times a second. And with the more power behind it, the more power it gets. And we put in a diode, we have a space between two positive and negative on the poles. And we shoot electricity, that zap, because electricity goes point to point. It jumps from magnetic field to magnetic field. It doesn't like being in space. So it needs enough power to get from point A to point B before it'll jump. The magnetic field is there. It's already in place. This is why you get the double slit. They used it with electricity. You get the double slit with the zap, the 1 point, and they get their whole wave collapse and all that stuff because it goes from point to point. That's electricity. And what happens is that is plasma. Why do I say that? Because it's supposed to be electrons and protons. We look at electricity like it's electrons. It's electricity. And we say, where are the protons? Well, when we do the diodes, actually all kinds of radiation comes out of that. All kinds of radiation. All high-end, high-powered radiation. Very similar to all the high-end, high-powered radiation coming out of the sun. And the bigger the zap, the higher end all the radiation coming out. They were noticing holes in the plates and stuff back in the day when they first started using diodes. They were noticing holes, and they couldn't figure out what it was, and they came across with protons out of some random atoms that were still in the air, but the longer you got it going, the more protons you end up with. Think about that for a minute. Another thing we did was we separated the electric charge to as small as we could get it, turned it into a tiny little vortex, electric charge from electricity, and then we did the same thing with the proton, and it was the same weight. We call it a positron. But that you got to think about too, because for your more high-end science guys that are sitting there going, "No, that's antimatter and antimatter." It's the positive and negative electrical charge. Okay, they zip around. Electromagnetism. What's the difference between that and a proton and an atom? That's what's going to bug people out when that comes up. That's coming up also. It's our understanding of how the atomic structure works that has changed, and it's changing our technology very quickly.